Hi everyone. I'm going to discuss FE Reference Handbook 10.2. This is the only resource, as you know, you can use during the exam. It's a long exam, of course, like 5.5 hours. So if you learn this handbook very well, of course, know the information in this handbook where you can find the formulas, tables, and so on, definitely it will be a game changer. So during the practices, like solving a problem or something, definitely you need to open this and use the digital version. So I will start with one of the most common question types that you always see in FE exam. It's the determinants of structures. So this information, for example, is given in page 271. I use manual navigation, as you can see. So definitely this is what you should do also, because like searching a common uh, keyword like structure, for example, will give you maybe 100 results. So I definitely don't want you to use this search option. You will remember, don't worry. Just if you use the handbook so much, you're going to remember the locations. So let's start with a truss determinacy check. So this may be a simple truss, for example, that you may see during the exam. So I will try my best to draw this. So we have pin supports. So as you know, all those joints are here are pin joints. So in trusses. And the supports, if you have pin supports, we have two unknowns, as you remember. We have y and x components for each case, for example. So that means we have two unknowns, two reactions here. So 2 and 2, the total number of reactions will be 2 plus 2, of course, 4. Now, how many members we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 members. So you're going to write 11 members. And during the exam also, I definitely recommend sketching the problems, because just looking at the screen, you may miss some of the information. So the number of joints here, we are going to count all these joints: 2, 3, 4, 5, 6, 7. So we have 7 joints. Let's apply the formula here: m plus r. M plus r, 11 plus reactions 4, 2 times 7. So what do you get? 15. Is it more than 14? Definitely. So that means this truss is stable and studying the indeterminate. So if you change one of the supports, for example, and make it like a roller, that will be just going to reduce number of reactions. It will be 3, for example, and this equivalency definitely will be 14 equals to 14, and that's going to be stable and statically determined. So you can play with the variations and so on. Definitely solve as much as you can similar questions like this. That's obvious that they are going to ask you this. Uh, Now let's give an example for frames. This may be a simple frame. For example, you may see we have a pin support, a fixed support. And fixed supports, the only difference, you're going to have moment also. So x, y components. So 3 unknowns like reactions comes from here. Here again we have 2. So reactions, number of reactions, you will get 3 plus 2 equals to 5. Let's put a hinge here, because in frames they want you to look at number of like internal moment of zero, like at a hinge. So special condition, let's say it. So c equals to 1, we have only one hinge. So after counting number of hinges, let's say if we have 3, write 3, of course. But after that, you just ignore that you don't have any hinge Okay, so when you count the number of members, you're going to count 1, 2, 3. Okay, so you're not going to split this member because of having hinge. Okay, so that's the confusion. Generally, don't do it. And joins, for example, again, we have 1, 2, 3, 4 joints. Okay, so you're not going to count again hinge. So you're just again ignoring that. So let's apply the formula. So applying the formula 3MR, is it equal or less than 3JC? So 3 times 3 plus 5, 3 times 4, as you can see, plus 1. Is it 9, 14, 13? So it is more. That means again this frame is stable and statically indeterminate. If you want to change again, make this fixed support, for example, pin, that will be stable and statically determined. Again, just changing and playing with the numbers, you will see it's going to work for all types of questions.